Hello students, in my last video I have discussed about Bell number. So now we will discuss about the Catalan number. Now let us first define what exactly is Catalan number. Now the sequence B0, B1, B2 dash 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 of positive integers defined by B0 is equal to 1 and Bn is equal to C 2n comma n upon n plus 1, which is also equal to 2n Cn upon n plus 1, which is also equal to 1 upon n plus 1. How to open NCR? 2n factorial upon n factorial into n factorial. Okay. So what I am saying, the sequence B0, B1, B2 of positive integers defined by B0 is equal to 1 and Bn defined by this formula is called the Catalan series, and the numbers are called Catalan number. So basically this is a Catalan series and all these numbers are the Catalan numbers. It is also expressed as, the Catalan number is also expressed as 2nn minus 2n n minus 1. This is also the representation of NCR, right? So 2nCn minus 2nCn minus 1 also give the series of Catalan numbers. So now let us try to write down this series. So now if I am writing the series, the first number, as I said, is always 1. Now if I want to write down for B1, so I can use either this or this or this. So now if I am putting n is equal to 1, so B1 is equal to, I can write 2C1. See, it is 2n. So 2 into 1 is 1, 2, and n is equal to 1. Upon n plus 1 means 1 plus 1. So 2 factorial upon 1 factorial into 2 minus 1 is 1 factorial and into 2. So this is 1. So B1 value is also 1. Now if I want to find out B2, okay, so how I'll do B2? Now in this formula, either you can use this formula or you can use this formula, whatever you prefer. Okay, so I can write this also as 1 plus 1 and 2n factorial upon n factorial square. Right, now let me do here. If I am putting n is equal to 2, so I'll have 4C2 upon 3. 2 plus 1 is 3. Right, now how to open 4C2? You can use calculator directly. 4 factorial upon 2 factorial into 2 factorial into 3. So 4 factorial is what? 4 into 3 into 2 into 1 upon 2 into 2 into 3. Right, so it is 2. So B2 value is 2. Similarly, I can find out B3 value, which is equal to 5. I can find out B4 value, which is equal to 14. I can find out B5 value, which is equal to 42. Same way I can find out all the numbers of the series. Okay. Now, sometimes they ask this type of question, ki find the value of, say, B8. Right. So if I want to find out the value of B8, now what is my Bn? Bn is n plus 1 denominator, 2n Cn. Right. See here, 2n Cn upon n plus 1. Right. So I wrote the formula. So let me apply this formula on B8. So 2 into 8 is 16. So 16 C8 upon 8 plus 1 is 9. So this is 16 factorial upon 8 factorial into 16 minus 8, that is 8 factorial again, into 9. Right. So this will become 16 into 15 into 14 into 13 into 12, okay, into 11 into 10 into 9, and 8 factorial will get cancelled. Right. So I'll have this upon again 8 factorial. So 8 into 7 into 6 into 5 into 4 into 3 into 2 into 9. So I can cancel all the term, but the smart way is take your calculator. There is a term NCR in your calculator. Put 16, shift NCR, and R is 8. So directly you will get the value. You don't have to calculate. So 16C8 you will get from calculator. That value upon 9 will be answer. So if you put in the calculator, your value of 16C8 is 12870. So 12870 upon 9 is nothing but 1430. So this is the value of B8. Similarly, I can find out the value of B9. So B9, if I am doing, put in the formula 9 2s are 18. So 18 C9 upon 9 plus 1 is 10. So in calculator, find out the value of 18 C9 and then divided by 10. So you will get 4862. Similarly, you can find out the value of B10, which is equal to, see now 10 if I am putting, so 20 C10 upon 11. So this value will be 16796. So this is how I can find out all the Catalan numbers. Okay. Now there is one simple question based on this. Now write down the question. Using definition of Bn. Using definition of Bn, prove that Bn plus 1 is equal to 2n plus 1 Bn upon n plus 2. So let us start from left hand side. So if I start with Bn plus 1 as per my formula, okay, as per my formula, I will be using this thing. I am writing here so that you will be more clear. I know that Bn is equal to 2n factorial upon n plus 1 and n factorial square. Okay, that I told you the 3 versions. So this is the third version I am taking. Right. Now what I'll do, and remember in all the cases n is always greater than or equal to 1. Now Bn plus 1, if I am applying this formula, in place of n I should put n plus 1. So I'll have 2n plus 1 factorial. Remember factorial is outside. Okay. Then n plus 1 plus 1. In place of n I should write n plus 1. Then n factorial means n plus 1 factorial square. Correct? Now this is equal to, if I observe, this is 2n plus 2 factorial. Denominator is n plus 2, n plus 1 factorial, n plus 1 factorial. Correct? Now as per the definition of factorial, I know how it works. If I have 4 factorial, it is equal to 4 into 3 factorial, right? Or if it is n factorial, it is always n into n minus 1 factorial. This is a basic definition of factorial. So if I apply in the numerator, I will keep on reducing it by 1. So 2n plus 2, 2n plus 1 and 2n factorial. So it is like that. If I have 4 factorial, I have written it as 4 into 3 into 2 factorial. Same thing I have done. Now denominator what I have? N plus 2. Okay. Now n plus 1 into n factorial and n plus 1 factorial. Right? Now if you look at this again, my target is to bring Bn into picture, because as I am proving the result, I should have Bn and I should have this expression. So if I am looking for this 2, I can take 2 common from here. So this 2 though came out. So I am left with n plus 1. Okay. In the second term, I have 2n plus 1, which I actually need. See, 2n plus 1 I need here. Correct? So 2n plus 1 is also there. And 2n factorial is also required for this definition of Bn. Right. Now in denominator what I have? In denominator I have n plus 2, which is required. Correct. Then I have n plus 1, which is not required here, but in definition of Bn I need. So I'll write 1 n plus 1 here. Okay. And after this I have n factorial. So n factorial is also required, and one more n factorial is required, so open this also. So I will write n plus 1 and 1 n factorial will come from here, and 1 n factorial is here. So n factorial square it became. Correct? Now observe very carefully. This is the definition of Bn, and this is what? This is looking like Bn. So I can replace this term by Bn. So now I have 2 n plus 1 and n plus 1 cancel. 2n plus 1 upon n plus 2 and Bn. If you observe, we got the right hand side. See here, we have got the right hand side, hence proved. Right? So this is the basic questions of Catalan number. Now my next question comes, where it is used? What exactly is the Catalan number, where it is used? See, actually it is a random series and a sequence, and we have observed it in many real life problems. Like many situations occurs when you will get the Catalan numbers. Okay, I'll give you a few examples, then we'll do some questions on the example. Now for example, suppose you have even number of people sitting across a round table. Okay, so you have even number of, what is the situation? You have even number of people sitting across a round table and they are shaking hand without crossing the hands. Okay, hand should not be crossed. Then how many ways they can do it? So my answer is, the number of ways is Bn. And since I am talking about an even number, so when I am saying 2 people, so that counts as B1. So let us see one example. Suppose there is a round table like this. So I am saying n is equal to 1 means 2 people are sitting. N is equal to 1 represent 2 people because I am talking only about the even number. Right? So how many ways they can do the handshake? Only one way. So B1, I know that it is 1. Correct? Now this is case 1. If you talk about case 2, now I have 4 people sitting. Now if 4 people are sitting, see, one is this, let me name it to make it more clear, C and D. Now how many ways they can do the cross handshake without crossing each other? So AD and BC cannot do, because if they do so, their hands will be crossed. So how they can do? AB can do and CD can do. And the other way how it can be done? AB and CD is here. So they can do AC and BD. So when 2 pairs I have, I can do it in 2 ways. We know that the value of B2 is 2. Right? Now come to the case 3. Now I am talking about case 3. Now case 3 means 3 pairs. 3 pairs means 6. So let me make 6 people sitting. 1, 2, 3, 4, 5 and 6. Correct? So now how many ways they can do? See, one way is 1, 2 and 3. Correct? The other way, draw 6, 1, 2, 3, 4, 5 and 6. So how they can do? 1, 2 can do, 3, 4 can do, 5, 6 can do. This is another combination. Okay. Now the other way, if you again draw the same thing, you make 1, 6 are doing, 2, 3 are doing and 5, 4 are doing. You can make a circle and put like this. Okay. In other way you can do 5, 6 are doing, 1, 4 are doing, 2, 3 are doing, then 1, 6, 2, 5, 3, 4. So if you make the circle, place the people and join the hands like this. So 1, 2, 3, 4, 5. So when I have 3, it is 5 combination. Means it represents a Catalan sequence. So in case 4, if I take 4, n is equal to 4. So my answer will be B4. Okay. Same way I can, if I say if 8 people are sitting, not 8 people, if 8 pairs are sitting, right? So I can tell you the answers. So if I have, suppose like we solved in the previous case, what is the value of B8? So when I'm saying B8 means I'm talking about 16 people sitting. So they can do the handshake in how many ways? So what was the value of B8? So I should know the value of B8, and I have told you how to evaluate B8. That was 1430. So 1430 ways they can do the handshake. So there are many real life problems where I can observe the Catalan series. I'll give you one more example. There is a product in that. How we can make the parenthesis to get the product. That also forms the Catalan series. Now one more example I'll give. Now suppose we arrange 2n numbers in two rows. 2n numbers are there and we are arranging them in two rows. Okay, and what is the restriction? First, the number increases from left to right. And second, the number at the top is smaller than bottom number. Okay, so now case 1. If I take case 1, suppose you have two numbers, right? Two numbers, again, as I said in the previous case, it will be counted 1. So if there are two numbers, how you can arrange 1 and 2? This is the only possible arrangement. So I will say B1 is equal to 1. Then if I say case 2, case 2 means I have 4 numbers. 4 numbers means 1, 2, 3 and 4. So how I can arrange them, right? So what will be the first arrangement? 1, 2, because it should increase when I am moving left to right. And the above number should be small. So 3, 4. This is one arrangement. What is the other arrangement? 1, 3, 2, 4. So B2 is equal to 2. Correct? Same way, if I take the another case when I have 6 numbers. 6 numbers means 1, 2, 3, 4, 5, 6. So now all of you can pause the video and try to write down all the possible combination and check whether it is equal to B3 or not. If you remember, the answer for B3 was 5. So I can arrange these numbers in 5 different ways with these two restrictions. So now quickly check whether you can write or not. I'll write the answer. You cross check the answer. But you should pause the video and try it yourself. Correct me if I am writing anything wrong. So this way, more than this I cannot write. So same way, if I take B8, if I am saying, means I have the numbers till 16. So how many times I can write? How many combinations I can write? 1450, because B8 value was 1450, 1350 something we calculated here also, right? 1430, sorry. Right? So this is how in real life example our Catalan numbers come into picture. Right? In exam usually they ask the values like find out B8, find out B9 or that derivation which relate Bn plus 1 and Bn. Now there is one more category in this which I'll explain you now. Now suppose if we have xy plane, okay, if you have xy plane with 0 as origin, right, and P is the point with coordinates n comma n. If we want to go to P from origin, okay, and I can do this only by two types of moves. I am allowed to take only two types of moves. The first move is defined by the function x comma y. It can go to x plus 1 comma y. And other one is upside x comma y implies x comma y plus 1. Let me first explain you what is the meaning of this. See, this, when I am writing this, it means that if you are sitting at this point, the coordinate is x comma y. So what type of movement is possible? Ki x can, here horizontally I can reach to x plus 1. Okay, and y will remain same. So this move is possible like chess. And the other, this u move whenever I am taking means if I am sitting at x comma y. So where I am moving, y is increasing, means I am going here. So either I can move 1 unit here or I can move 1 unit here. Okay, so with this restriction when you move, without crossing the line y is equal to x, this type of path is called the good path. So I can observe my Catalan number in good path also. So first you need to understand what is a good path. Good path is nothing but if you are moving from 0, 0 to n, n in such a way that only these two moves are allowed and you cannot cross the line y is equal to x, then it is called the good path. Now let us check how the Catalan sequence I am getting here. Now let me take one simple example. Suppose you are in a xy plane. Let me make it. Correct? And you want to move from 0, 0 to 1, 2, 3. So here 1, 2 and 3. Here. You want to move to 3, 3. So now you want to go to this. This line is y is equal to x. So my restriction is I should not cross this line. I should not go above this line. And I want to reach at this point. Correct? So I can follow only these two types of route. Now think, if I am starting from here, how I can go? R, R, R. Because R move me 1 unit towards right. Right? So I can move like this. R, R and R. So I reached here. Now I want to go up. So I will do U, U, U. So this is one way to reach. Now look at the other way. Suppose if you go like this. Let me change the color. Suppose I go like this. So I have followed R. Okay. Then I'll go like this. So U. Correct? Then I'll go like this. So R. Then I'll go like this. So U. Then R. Then U. So I reach the destination. So this is how you have to find out all the possible path. Now pause the video and figure out the different path. Now see the other path which I can write. I can go like this. Here, here. Okay. Then here, here. So R, R, U, U. Then R and U. Again I reached. Right. So what path I did? R, R, U, U, R, U. Correct? So this is how I got one more path. Now the other path is, try to figure out more path. R, R, U, R, U, U. R, U, R, R, U, U. So how many path I got? I got 5 path. And I moved till 3, 3. So B3 is what? B3 is 5. Correct? B3 is 5. So this is how I got the answer. So suppose if you want to move from 0, 0 to n, n, how many ways I can move? I can move by bn ways. If it is 5, 5, my answer will be b5. If it is 8, 8, my answer will be b8. So this is how we define the good path, and we can see a Catalan sequence in case of the good path with the restricted moves. Right? Now how I can frame a question based on this? Usually on example they don't frame the question because there are so many examples. More you read, more interesting it will be. So I will suggest all of you to Google more and more example and work on it. So let us do one question based on this. Now use r x comma y, x plus y comma y, and u x plus comma y is x comma y plus 1. Find how many ways can one go? First part, from 0, 0 to 6, 6, keeping line y is equal to x. Okay. And second part, from 2, 1 to 7, 6 with line y is equal to x minus 1. Now let us see the solution for A part. Now it is the first case from 0, 0 to 6, 6. So I said from 0, 0 to n comma n, how many ways I can go? By bn ways. So my answer will be b6, right? And what is the value of b6? 1 upon 6 plus 1, 12 c6. That is the formula we have already practiced. So answer will be 1, 3, 2. Correct. So A part to easily I got. Now B problem, there is a problem. I can tell the result as Bn only if I am moving from 0, 0 to 6, 6 across y is equal to x. But neither this is 0, 0 nor it is n comma n nor it is y is equal to x. So what I'll do, I'll change the scale. How I'll change the scale? I want to make this 0 comma 0. So I'll define a new x which is nothing but x minus 2 and new y which is y minus 1. So now if I put x is equal to 2 here, 2 minus 2 is 0. So the point 2 comma 0, sorry 2 comma 1 will get converted to, here if I am putting x is equal to 2, 2 minus 2 is 0. So 0. And if I put here y is equal to 1, 1 minus 1 is 0. So basically this small xy got converted into capital X comma y through this, and I got the first point at 0 comma 0. Now let me check what will happen to this point. Now capital X is x minus 2. If I put here 7, 7 minus 2 is how much? 7 minus 2 is 5, right? So 5. Same way 6 minus 1 is what? 5. So now I am moving from 0 comma 0 to 5 comma 5. Okay, now I am moving from 0 comma 0 to 5 comma 5. Now what was the line given? Y is equal to x minus 1 is the line given. Correct. So now I should change it into capital X and capital Y. So what is the value of small y? Capital Y plus 1 is equal to, what is the value of small x? Small x is capital X plus 2. So capital X plus 2 minus 1. So y is equal to x. So see, I got the same scenario from 0 comma 0 to n comma n along y is equal to x. So answer is B5. And we all know what is the value of B5. So this is how we can do the question. So this is all about the Catalan number, but I will suggest you read on many cases where you can apply the Catalan numbers or you observe the Catalan series. As I said, there is a very common example to get the product of n number, n minus 1 multiplication involving two factors at a time. The number of ways expressing the product is bn minus 1. So that is also a common question, right? So this type of different questions and cases you can go through, but usually in exam they ask you the values. So now we are done with Bell numbers, we are done with the Stirling numbers, and we are done with the Catalan numbers. So I will soon upload the video on a principle of exclusion and inclusion. So I'll suggest you to subscribe the channel so that you will get the notification for the latest updates. If you want any other topic, you can text me. I will upload the topic. Thank you.